Hey class, it's Bill back with another video in our Getting Reacquainted with Object-Oriented Programming for Java 2. We have spent some time creating some design documents. We created a class diagram and we created a UML object diagram, and then we started writing code. So we have a working bank account and bank. But we want to switch gears and look at something slightly different, and that is about testing. A couple of things to get you motivated about this topic. One is, more often than not these days, testing organizations have gone away in major companies. Programmers are expected to turn in their code already tested. They're expected to do more unit testing, which has always been a good plan, but even more important if testing organizations have been de-emphasized. So you can't count on the fact that you're just going to give your code to somebody else and they're going to test it. You want to turn in code that is great and that is doing the things it's supposed to do, and certainly free from the common kinds of bugs that are so easy to create. Another thing that's good about knowing this is that when you go for an interview and your potential employer finds out that you understand about testing and you understand the value of testing, especially unit testing like this, they're going to be happy because they don't have to teach you why it's important, and they don't have to maybe teach you the basics of, the basic kind of things that test cases do for you. So this is a really valuable thing. Now, one thing else to say is, I know it doesn't always seem like exciting work. Some of it seems kind of perfunctory, sort of basic. So a couple of things to help. One is, if you do test-driven development where you write your testing first, it won't seem as boring because you'll be writing to guarantee that you have thought of all the interesting stuff that you can then ensure that your code is doing correctly. Another way to think of it that's fun is, think about running your tests on somebody else's code. Right? So maybe you think you're very clever and you wouldn't miss these things, but maybe somebody else would not have thought of all the clever things that you did. And you can think, I bet that other person across the aisle from me is maybe not as clever. I'm going to write this just to make sure that that was done correctly. So if you think of it that way, sometimes it can seem like a little more fun, but certainly it feels very good to be able to click a button and have all of your tests run right before you submit your work. At school, you can click that button and you get all those unit tests run. You know that you didn't make any big mistakes at the end that messed it up. And at work, same thing. You can run all your unit tests right before you turn in your code, submit your code to whatever kind of source repository that your job is having. Then you definitely know that you feel a lot better about submitting your code. So hopefully that's enough of a reason to want to do it. So now let's actually talk a little bit about it. One of the things that I like about BlueJ is that it supports JUnit testing. JUnit is a common framework to write tests in, and so it's a common thing in the industry, and it's also a good general thing to learn. Even if your company doesn't use exactly this, they probably have something that's going to be, in the ballpark, and knowing the basics are good anyway, even if they use something slightly different. So JUnit is the Java equivalent to this, and you can do that right in BlueJ. It has good support for JUnit testing. So the thing that you want to think about is, for every production test class, and I'm talking, when I say production, I mean the stuff that we've written already, right? The stuff that we're going to ship to customers for them to use. For every one of those classes, you should write a test class, and in general, for every production method that you have, you should write a test method as well. We're going to say sometimes you can collapse that a little bit, and then of course we're going to learn a little bit about preconditions and how to test those. So there's a lot of interesting stuff coming here. But let's take a peek now at how we're going to do that to our little classes that we've created here. Let's start with bank account. Again, that was our first one. I would argue that you should probably test bank account before you even start writing bank, because then you know that the fundamentals of that class are good, and if you're building on those as building blocks, you know that they're solid, and if you build on them, that's an okay thing to do. So one thing you can do here, I will right click this and say create test class. If you do that, it creates a little shadow test class, and BlueJ in its project file knows to keep those two things together, so it takes up a little less real estate, which is really nice. So that's a good thing to do, just right click. Now the other thing is that you see there's a little expando thing here that maybe you haven't noticed before, but there it is. If you click that, then some UI shows up about running tests. Right now we don't have any tests, so if we click run test, there's nothing much that it can show. It's just going to say there wasn't anything there, but that's going to be the magic button that's going to make everything happen. Now, one other thing to note, everything has to be compiled before you run your tests, or else it won't run the current set of tests perhaps. So always hit compile, and if you do it here, it'll compile everything that needs to be compiled, and then you hit run tests. So what are we going to test here? Well, it may seem kind of basic, but we don't want to test everything. We want to make sure that every single thing that we did in here, every method that we did, every single thing we wrote, all of the state in the object is all tested, because it's just kind of easy to do that wrong. It's easy to copy and paste and not remember to change something that you should have changed. It's just easier to do it than you think. Now, it's going to have a bunch of stuff up here that I won't use right now. There is a constructor for the whole class. It is a class. There is this setup and tear down, and if you write any code there, that code will be run before each test case, and this code will be run after every test method, right? So we will write some tests down here, and if you want to use this stuff later, great, good for you. For the moment, we can sort of delete all that stuff. I'm just going to delete this so I have a little bit out of the way, and sure, so this is good. So I'm going to start down here and show you the basics of writing a test case. The way that you write a test case, in fact, I'm going to move this down some too. In fact, I'll just move this down instead so I have lots of room. The way that you write a test case is that first you start with the annotation @test. When you write that, when you write the @ this is not a signal to the compiler, this is a signal to something else, right? To some other system that's going to happen before, a pre-compiler option. So that is signaling the test framework that a test case is coming. Then you're going to write a public void method, and you're going to name it according to what it is you're going to test. So let's just say for most objects, a good way to start is test constructor. Right? And so you're going to write a public void method called test constructor. In it, we want to test the constructor for this class, right, for the bank account class. And so how do we do that? Well, let's go first, open this code, and here's another clever thing you can do in BlueJ. If you do this, you can say move tab to new window. So what you can do here is I can put the bank account on the left and the test code on the right, so I can always see what I'm doing here. Right? And of course this is a little big, but you can get the idea. So in this case, the first thing I have to do when testing the constructor is I have to run the constructor, right? So I have to make sure I do new bank account, and I'm going to give it a name, Joe Schmo, and I'm going to give it an ID, and I'm going to give it a balance. Okay, so over here I have all of that stuff. Why is that not scrolling? Does it not? That's kind of odd. Oh well, okay. So I can certainly break this if it helps for you to see it. Okay, so I've created that. I've run the constructor. All that I have done so far is test that it hasn't blown up. That's something, but maybe not quite what I wanted. So maybe I do bank account test account equals, right? And I'll wrap this again so you can see it, but obviously you don't have to wrap it quite so much. So we've created the new bank account. Now that's something. I've run the constructor. I've assigned it to an object reference, right? A variable that contains an object reference. But really, testing the constructor and the get methods are really kind of integrated, because I want to know that all that information found a home in the right place. I want to know that the name got stored in the instance variable and that I can retrieve it. That proves that sort of full circle. Yep, it got stored and I can get it back. So the thing that I want to test is not only that the thing got constructed, but that all the data found a home. The way that we typically do comparisons, the way that we run actual tests here, tends to be this. You say assert equals. And that means I am asserting, I believe, that if I call this particular method, which is testaccount.get, and then what is that called? It is getOwner. Right, and I still don't know why this is acting so weird in terms of the window. Maybe I'll move it over a little bit. Yeah. All right, so what this is saying is, if I call this, I expect this to be the answer. Right? First you put the thing you expect, and then you put the call that actually retrieves it. So you're saying, hey, I believe that when I call this, this better be the answer. If it's not, it's going to be a failure for that test and you're going to see an error. If it is true that that works the way you expect, then great, then that's a pass and you won't see any particular error for that. Likewise, I'm going to do that with the ID, and so instead of get owner, I'm going to call get something. Again, control spacebar. I'm going to call get ID, and then what do I believe the ID should be? 1, 2, 3, 4, 5, right? So that's great. So if we just save that, compile it, if we go back now to our project and compile there, we can say run tests, and look what we'll see. That test method runs, that test method passed, and in fact all of them passed because we have this lovely green bar to say everything's good. If something had gone wrong, we would see something different. How do we know that, or how do we see it? Well, let's say we miss an E here, right? Let's say we expected the wrong thing. And we compile, we run the tests, and now you'll see, not true. You click on it, you'll see I expected this, but instead it was this. And notice it even highlights the difference. This E is different than what it expected. You can also see the whole call stack, and you can say show source, and it'll take you to the line. So all of that is very useful. That's the test UI that we're going to get provided with BlueJ. So if we do this correctly, then everything's working great, and our tests will all pass. Now what about the balance? We're going to probably copy and paste that line, and I'm going to say get balance. Notice again I'm lazy. Control spacebar is my friend. Now if I try to do this, it's not going to run correctly. It's going to compile, but it's not going to run correctly. The reason is if you're comparing floating point numbers, you can sometimes get, because of if you calculate them two different ways, you can get a slight difference in precision, right? So what you really want to say here is I want to say that these things are pretty darn close to equal. So when you're comparing a double or a floating point number, pretty darn close means you need a third parameter. Something like this, like it ought to be not even a penny off, right? It ought to be so close that it's fractions of a penny, and as long as it's within 0.001, I'm considering that good, right? That's almost equals. So always need that third parameter only for floating points and doubles, right? So again, compile, go over here, I can compile it here, run the tests, everything's good, everything passed. So in general, what you want is one test method for every production method. But when it comes to the constructors and standard gets, I think it makes sense to put them together because you kind of need the gets to test the constructor fully. So otherwise, don't overload these. Don't lump too much else in here. For instance, in this case, maybe I would do the set methods, test the sets, right? And I don't have very many tests. So again, I need a new account. So I'm going to take this account and I'm going to then change the name. So I'm going to say test account.set owner, and I'm going to give a new name. And maybe this is Jolene Schmo. Joe is now going by Jolene. No judgment. If Joe wants to be Jolene, good for Joe. Okay, so in this case now I'm saying I'm setting the owner. I'm actually calling the thing, right, that's going to set the owner, and then I'm going to make sure via an assert equals that that new owner was also set, right? And so in this case, instead of Joe, I should expect Jolene. Okay? Now again, I'm going to go back here, hit compile, hit run. Both of these run. Everything is working particularly well. Everything's good. Okay. I'm going to continue down that vein, but I want to show you how to test some things that maybe aren't as straightforward. Obviously, it's easy to test things like deposit and withdraw, make sure that the amounts that come back are right, etc. But let's test something that's a little bit harder, like the fact that the initial balance is not supposed to be less than 0. The way that you do that is interesting because if I just start down this road, public void test constructor null or balance negative, right? I tend to name these things. I know my names are a little long, but if I see something fail, I know exactly what was being run there, right? So I get a pretty good clue. So if I just did something like this, a new bank account, and then I put in, I don't even care, all right? And I'm going to put in a negative balance. What I often do with these kind of tests is I put in values that are obviously just stupid, because I don't care what the name is and I don't care what the ID is. I'm really just trying to make sure, right, that this particular thing is being tested. This is the only real thing that's interesting. So the rest I just put like nines or something that's a signal to my eye that says, don't worry about these parameters. That's not really what's being tested. And notice, because I'm looking for balances less than 0, I'm going to try the closest thing to 0, which is -1 penny. Now, if I run this code, the problem is that this is going to throw an exception, right? Or it should throw an exception. If so, that's going to break my tests. If I go now to compile this thing and run it, it's going to say, right? It throws an illegal argument exception, which blows up my test and gives me a very unhappy big red bar. So what I need to be able to tell this thing is, hey, what I expected equals, what I expect is an illegal argument exception, and then you have to put .class on the end. Why? Just because you have to, right? It needs to have a class name there, right? Not an actual exception, but the class from the exception. So in this case, you're saying, hey, when I run this test, I'm expecting an illegal argument exception, and in fact, if I don't get that, that's a failure, right? It needs to be, and it can't be some other exception. Literally, I need to see that happening. So now when I compile and I run, everything's happy, right? All passing tests. The other thing that's interesting here, notice I didn't have to even save it, right? There wasn't any point. I just had to run the constructor. I don't have to write assert equals. There's really nothing else I have to do. That was enough to test it. The only thing you need to realize here is code here will never run, because when it runs the constructor, it throws the exception and this thing grabs it, so no code below this line would ever run. So when you are testing preconditions, things that throw exceptions, you get exactly one chance, one thing to do here that throws the exception, and if you want to test another one, you got to come down here and do another test method, all right? So that's just a little bit about how that works. So hopefully you can see here that this is the idea that you would go down, right? The road that you would go down. I would probably have one method in here for testing deposits and withdrawals. I might combine those, but in general, you want one test method per production method. Combine them only when it makes sense, right? So I would do deposit and withdraw, and then I'd have a whole bunch of preconditions, right? Because everything I have over here, initial balance less than 0, I would test one for null. I would test one for empty. I would test this to test the set separately from the constructor. Again, you don't want to assume anything about this code, right? If you're writing this test code to run against some junior developer's code, you don't know if they did that right. So test a lot. Here you have another exception to test. Here you have another exception. Here you have another exception. So there's going to be a lot of these things down here, right? So sometimes up here, I will label this whole set as being something like this. This is the happy path tests, and to me happy path means everything is sunny, everything is going right, the client code is calling your supplier code in a way that you that everything is good, right? So I call these happy path tests, and then maybe I call these precondition tests down here, or tests that throw exceptions, tests that expect exceptions. So this section maybe is big or bigger than everything up there. Now obviously in this class we wouldn't have too many more tests than this, except again a lot of exception tests down here. But in bank it's a little more complicated, because in bank you have to also test the interactions between the bank and the accounts. You don't retest this stuff, right? The whole point of a unit test is that now we know that the bank account is tested. We don't retest the bank account stuff. But in bank, you certainly will have to go in and think about testing the relationships, right? So for instance, when we get to bank, we have to think about, how do we test open account? How do we test close account, right? How do we test get total balance? How many accounts do we need to have in there to make sure that that's correct? Well, more than one. How about get accounts below amount? Well, we need to have probably a handful of these to test. And what happens if there aren't any below that amount, right? That's the tester thinking. What if they're all above that amount? What if they're all below? What if there are none? So the bank is going to have more interesting testing to do, but you're still going to follow the same thing. You want to think about how you can test all the state, even though you can't get to these directly. You can get them. Remember, we found out we were missing a get method for the interest rate, right? That's one thing you'll find in your tests. You can't get directly to the accounts, but you can do get account, right? So you can definitely, you'll have more to do here, but you follow the same idea. So each one of these would end up with its own test class, and when you run tests, it will run all of them. And again, even though I know it's going to seem like a lot of work, and until I succeed in convincing you that this is a valid thing and something that is very useful to you in the long run, it seems like it's a bit tedious. But put on a different hat, think about testing somebody else's work, or consider really doing test-driven development for one project and see if it works. Stub these things, then go and write the tests, and then keep writing these until when you run tests, everything comes back right. Right, so that's another way to think of it. So that's a lot of information that we've talked about here, but hopefully some useful stuff for you. And so that's all about JUnit testing. And at that point, I think we're sort of done with this video because it's gone on a little bit long, but hopefully that's a good start. In this course, I am expecting you to write tests for most projects. If you don't have to write them, I'll certainly point that out in the project, but I'm expecting that you turn in well-tested work for this course in every project that you do with those exceptions. So thanks for watching this video. Hopefully it's a useful review for those who've been with me before or who have seen JUnit. And if it's new to you, then good. I hope that you're able to see the value and to use it in your projects right away. So thanks for watching, and we'll see you in another video.